In the summer of 1940, Britain was counting fighters the way a dying man counts breaths. Every morning, Royal Air Force squadrons rose to meet the Luftwaffe. Every evening, fewer aircraft came home. The Hawker Hurricane was the backbone of fighter command. It would destroy more enemy aircraft during the Battle of Britain than any other RAF fighter. But there was a problem no pilot could solve. The factories building them were in range of German bombs. Hawker's plants at Kingston and Brooklands sat in the crowded southeast of England, beneath the very skies the Luftwaffe intended to own. A single successful raid could erase weeks of production in an afternoon. The Air Ministry had run the numbers, and the numbers were merciless. Britain could build Hurricanes, but not fast enough, not safely enough, and not for long if the bombing intensified. The mathematics of survival demanded something that seemed almost absurd. A fighter factory the Germans could never touch, somewhere beyond the range of any bomber, somewhere with steel, with railways, with workers, somewhere an ocean away. There was such a place, a sprawling industrial plant on the frozen shore of Lake Superior, in a Canadian town most British officials could not find on a map. It had never built an aircraft. It built railway boxcars, and the person about to be handed responsibility for turning that boxcar factory into a fighter production line was someone no one in the Air Ministry, almost no one in the aviation world, would have predicted. But before that reveal, the blueprints first had to cross an Atlantic that would soon become a hunting ground for German U-boats, and that was only the first impossible step. Fort William, Ontario, sat at the head of Lake Superior, more than 5,000 kilometers from Berlin. No German bomber ever built could reach it. No German bomber on any drawing board could reach it. In a war where geography had become destiny, this remote grain port at the edge of the Canadian Shield possessed something London could not buy at any price: absolute safety. It also possessed the Canadian Car and Foundry. Can Car, as the locals called it, was a workhorse of Canadian heavy industry. Its cavernous plant had spent decades turning out railway boxcars, streetcars, and ship components. Big, heavy, forgiving machines built to tolerances measured in fractions of an inch. If a boxcar frame was slightly out of true, it still rolled. Nobody died. A fighter aircraft was a different species entirely. A Hurricane demanded tolerances measured in thousandths of an inch. Its wings had to survive forces that would tear a boxcar apart. A misaligned rivet, a poorly heat-treated fitting, an undetected flaw in a spar. Any one of these could kill a pilot 8 kilometers above England before an enemy fired a shot. In late 1938, with war looming, the British Air Ministry had placed its bet anyway. Can-Car received a contract to build Hurricanes under license. On paper, the arrangement was simple. Hawker would ship the drawings, Canada would ship back fighters. The paper lied. The drawings arrived by sea in early 1939. Crates filled with engineering drawings carried across an Atlantic that would soon become a hunting ground for German U-boats. And when the engineers in Fort William unpacked them, they discovered the first obstacle. The drawings alone were not enough. British manufacturing culture relied on decades of accumulated shop floor knowledge that was never written down. A British fitter at Kingston knew how a certain assembly went together because the man beside him had done it 1,000 times. In Fort William, there was no man beside you. There was only the drawing, and the drawing assumed you already knew. Worse, the materials lists specified British suppliers, British alloys, British standard parts. Many simply did not exist in North America. Every missing fastener, every unavailable steel grade forced a decision. Wait months for shipment across a hostile ocean, or find a Canadian substitute and prove, with engineering rigour on paper, to the satisfaction of British inspectors, that the substitute would not fail at altitude. Then there was the workforce. Fort William was not Coventry. It had no pool of trained aircraft workers, no tradition of aviation craftsmanship. The plant would have to take railway workers, grain handlers, farm boys, and, in numbers that would eventually startle everyone, local women, many of them Finnish and Ukrainian immigrants' daughters, and teach them to build one of the most advanced fighter aircraft in the world. Training programs had to be invented from nothing. Jigs and tooling had to be designed and machined on site. The factory floor itself had to be reorganized, because an assembly line for 40-foot boxcars flows nothing like an assembly line for fighters. Through 1939, the plant crawled forward, producing its first hurricanes at a painstaking pace, learning with every airframe, its output measured not in aircraft per week, but in lessons per mistake. In January 1940, the first Canadian-built Hurricane took to the air, proof, at least, that it could be done. But then came the fall of France, the Battle of Britain, and the transformation of a comfortable license agreement into a desperate lifeline. London no longer wanted a trickle of Canadian fighters. It wanted a flood. Production would have to multiply, not improve by percentages, but multiply. And the aircraft itself would have to evolve, because the Hurricane Canada had been licensed to build was already evolving over the skies of Kent. Everything now depended on one position, the chief aeronautical engineer. The person in that chair would carry responsibility for every calculation, every material substitution, every design modification, every signature certifying that an aircraft was safe to fly and fit to fight. Thousands of workers would follow this engineer's drawings. Hundreds of pilots would trust this engineer's mathematics with their lives. The aviation world assumed the job would go to some veteran of the British industry, a grey-haired man from Hawker or Bristol, shipped across the Atlantic to bring order to the colonies. The aviation world was wrong on every count. The new chief aeronautical engineer arrived on the factory floor with 2 canes. The sound came first, steel tips ringing on concrete, steady and unhurried, cutting through the din of rivet guns and overhead cranes. Workers looked up from their benches, expecting the grey-haired British industrialist of rumour. What they saw instead was a woman in her early 30s, dark-eyed and direct, moving through the sprawl of the plant with the deliberate rhythm of someone who had long ago made peace with a body that fought her and a mind that never lost. Her name was Elsie McGill. In 1927, she had graduated from the University of Toronto in electrical engineering, the first woman in Canada to do so. 2 years later, at the University of Michigan, she became the first woman in North America to earn a master's degree in aeronautical engineering. And in the same season as that triumph, illness struck. The diagnosis pointed to polio. Doctors told her she might never walk again. She taught herself to walk again on 2 metal canes and returned to engineering. In 1938, Canadian Car and Foundry hired her as its chief aeronautical engineer. Within a year, she had designed the Maple Leaf 2 trainer from the ground up and watched it take flight in October 1939, becoming the first woman to design an aircraft that entered production. Still, when she took command of the Hurricane program, the skeptics were waiting. Some were open about it. Most simply watched, arms crossed, expecting the experiment to fail. A woman, a disabled woman, signing the stress calculations for a front-line fighter? In 1940, the idea had almost no precedent anywhere in the world. McGill's answer was not a speech, it was work. She could not serve as a pilot herself, but she still insisted on experiencing the aircraft firsthand. She flew as an observer on test flights, feeling the machine's behavior from inside, rather than studying it only from a desk. When production drawings conflicted, the dispute ended at her table, and her rulings were precise enough that they stopped being questioned. When a British part was unavailable, she and her team engineered the substitution and stood behind the mathematics. Every airframe that rolled out the doors reflected engineering decisions that had passed through her office, calculations and approvals that amounted to a promise the numbers were right. The factory watched her cross those vast floors day after day, canes ringing on the concrete, stopping at stations to inspect a spar fitting or question a foreman, missing nothing. Skepticism has a short life in the presence of relentless competence. The men and women of Cancar came to a quiet, collective verdict long before the newspapers did. The program was in the strongest hands available, and it was not close. The wider world caught up eventually. By 1942, newspapers, magazines, and even comic books were celebrating her under a title the workers of Fort William already understood, Queen of the Hurricanes. But that fame lay ahead. In 1940, there was only the work, a factory still learning its trade, an ocean full of U-boats, a Britain burning under the Blitz, and an engineering war about to begin in earnest, fought not with guns but with slide rules, against an enemy no one in England had thought to warn her about. The Canadian winter was coming, and the Hurricane had never been designed to survive it. The first battle was fought over engines. Every early aircraft built at Fort William depended on Merlin III engines shipped from Britain, engines already in overwhelming demand across Britain's own aircraft industry, carried across an ocean where U-boats were sinking freighters faster than shipyards could replace them. By 1940, the arithmetic was unsustainable. Britain could not spare the engines, and the ocean could not guarantee their delivery. The solution lay south of the border. The Packard Motor Car Company of Detroit had signed on to build the Merlin under license in America. But Packard's version was not simply built bolt for bolt. The Americans adapted the Merlin to their own manufacturing methods while preserving its essential design. A Packard-built Merlin 28 was a Merlin in name and lineage, yet installing it in an airframe designed around the British original meant reworking mounts, systems and fittings, then proving the whole marriage on paper before proving it in the air. This engineering and its consequences defined the Canadian Hurricane family. The Mark X carried the Packard Merlin 28. Further Canadian refinements followed before production reached the definitive Hurricane Mark XII. Each variant meant fresh calculations flowing through McGill's office: weight and balance, cooling, stress paths, because in aviation there is no such thing as a small change. Change the engine and you have changed the aircraft. Then came the enemy that flew no flag. The Hurricane had been designed for the comparatively mild climate of northwestern Europe, damp, temperate and forgiving. Fort William's winter was none of these things. Temperatures fell past 40 below. Oil thickened to sludge. Rubber turned brittle. Ice sheathed wings and jammed control surfaces. A fighter that performed flawlessly over Kent could become a frozen hazard on a Lake Superior airfield, and Canada intended not just to build Hurricanes, but to fly them in home defence over exactly this kind of country. McGill's team attacked the cold systematically. They developed de-icing measures to keep control surfaces and airframes flying in conditions the original designers had never imagined. Most strikingly, they engineered a way to replace the Hurricane's wheels with skis, letting the fighter operate from snow-packed fields, proving that a modern monoplane fighter could be successfully adapted for operations in Canada's brutal winters. Each adaptation triggered the familiar chain. The skis solved the snow problem but changed the aircraft's weight and drag. The changed loads demanded new stress analysis. The analysis revealed fittings that needed reinforcement. The reinforcement added weight that had to be found somewhere else. Problem, solution. New problem. The loop that is the true sound of engineering, quieter than rivet guns and just as constant. And the rivet guns never stopped, because the third front of this war was human. The plant's workforce swelled from hundreds toward thousands as orders multiplied. By the peak of production, roughly half the workers on the Hurricane program were women, an industrial experiment on a scale Canada had never attempted. They came from the towns and farms around the lakehead, many with no industrial experience whatever, and were trained in weeks to drive rivets, wire instrument panels, dope fabric, and inspect assemblies to aviation tolerances. The factory floor they entered was deafening, cold near the great doors, sharp with the smell of dope, cut metal, and machine oil. Shifts ran around the clock, hands cracked in the dry winter air, eyes strained under work lamps checking rivet lines 1,000 rivets long. The stakes of their work were never abstract. Everyone on the floor understood that a lazy rivet or a missed inspection would not fail in Fort William. It would fail over the North Atlantic, or above England, or on some frozen patrol out of a Canadian coastal station, and a young man they would never meet would pay for it. Inspection culture at Cancar grew fierce because the alternative was unbearable. McGill herself set the tone. No assembly shipped on hope. No calculation rested on assumption. The system was tested constantly. Substitute materials arrived that did not match their certificates and had to be rejected, whatever the schedule said. Subcontracted parts from workshops scattered across Canada came in with subtle variances that only revealed themselves at final assembly. Winter storms shut the railways that fed the plant its steel and aluminum. Each disruption rippled down a production line that was simultaneously being asked to accelerate. And yet, it accelerated. The learning curve that had cost so dearly in 1939 began paying dividends. Jigs were refined. Workers who had never seen an aircraft 2 years earlier were now training newcomers. Assemblies that once took days took hours. The plant that had needed most of a year to deliver its first handful of fighters was becoming something Britain had gambled on but never quite believed in. A mass-production fighter factory, out of reach of any bomb, running at full stride. What that stride produced, and what happened to the aircraft when they left the safety of Fort William for the most dangerous ocean on Earth, would settle whether the entire gamble had been worth it. The numbers tell the story of a factory transformed. In 1939, Fort William had struggled to complete a handful of aircraft. By the height of the program, the plant was rolling out Hurricanes at rates that would have seemed like fantasy to the men who first uncrated those incomplete British drawings. When the final airframe was delivered in 1943, the count stood at 1,451 Hurricanes built on the shore of Lake Superior. A boxcar factory, staffed largely by workers who had never touched an aircraft, had produced more than 1 in every 10 Hurricanes ever made. But building a fighter and delivering a fighter are different wars. Every completed aircraft first had to prove itself in the air. Test pilots took each machine up over Lake Superior, in summer haze and in winter air so cold that a forced landing meant death by exposure before rescue could arrive. They wrung out every airframe, hunting for the flaw that inspection might have missed, a control surface that fluttered, an engine that ran hot, a gear leg that refused to lock. Only when the aircraft had satisfied the pilot did it satisfy the contract. Then came the ocean. Hurricanes bound for Britain were partially disassembled, cocooned against salt air, and crated for the Atlantic crossing, loaded onto the same convoys the U-boats were hunting. The safety that geography gave the factory ended at the water's edge. Some of Fort William's work reached England and was reassembled to fly. Some of it went to the bottom of the sea, months of labour erased in the minutes it takes a torpedoed freighter to sink. The workers rarely learned the fate of individual aircraft. They only knew that the answer to loss was volume, and volume was the one thing the plant could now guarantee. The Canadian-built Hurricanes scattered across the Allied war. Early Fort William aircraft began reaching Britain during the latter months of 1940, as Fighter Command continued its fight for survival. Later marks served closer to home. RCAF squadrons flew Hurricane 12s on home defence duties from bases on both Canadian coasts, guarding the country's skies throughout the Pacific War. Some Canadian-built Hurricanes also found their way to an ally few workers would have predicted when the program began, the Soviet Union, joining the thousands of Hurricanes supplied through Allied Lend-Lease convoys that battled their way to Murmansk. On the Eastern Front, in cold that even Fort William would have respected, Canadian-built fighters flew against the Luftwaffe from the other side of the world. Precisely tracing individual aircraft through this global pipeline is difficult, and historians are careful about crediting specific batches to specific battles. What the record supports without qualification is this: the fighters kept coming. Through 1941, 1942, into 1943, while British factories endured bombing, dispersal and disruption, the plant, beyond the range of every German aircraft, never missed its stride for enemy action, because enemy action could not touch it. That had been the entire premise, sketched in desperation in 1940, a fighter factory the Germans could never reach. By 1943, the premise was proven, the contract complete, and the plant was already retooling for its next aircraft, the Curtiss Helldiver. The Hurricanes flew on. The question that remained was what history would remember, and what it would forget. The war ended, and the forgetting began almost immediately. The Hurricanes were scrapped, sold, or left to weather on forgotten airfields. The Fort William plant moved on to other contracts, other decades, other names. The city itself would eventually vanish into the amalgamated Thunder Bay. Elsie McGill left Cancar in 1943 and built a second, remarkable life as a consulting engineer and a leading voice for women's rights in Canada, work that occupied her until her death in 1980. The wartime comic book faded into collectors' archives. The workers went back to railways, farms and kitchens, carrying stories that fewer and fewer people asked to hear. Yet consider what had actually happened on the shore of Lake Superior. A nation with almost no aircraft industry took on one of the most demanding manufacturing challenges of its age, and delivered. 1,451 fighters, built from borrowed blueprints, powered by Merlin engines supplied from Britain and later the United States, assembled by railway workers and farm girls in a factory that had never built anything meant to leave the ground. The Battle of Britain depended on courageous pilots, but pilots fight with what industry gives them, and industry survives only where bombs cannot reach. Britain could build the Hurricane. What it could not build in 1940 was certainty. The certainty that production would continue no matter what the Luftwaffe did. That certainty had to be built somewhere else, out of boxcar steel and borrowed blueprints and stubborn northern winters, somewhere the bombers could never reach. Today, ships still pass the old Lakehead waterfront where the great doors once opened onto the cold. Most sail by without knowing, but for 4 years, through that harbour, Canada sent the sky its answer.